I'm Barry Johnston, and I'm a low-carbon lecturer at Glyndŵr University's Department of Engineering. Today I'm going to ask the question, how well do renewable energy technologies pay back the carbon and energy that are invested in them? And to do that, we're going to use a tool called life cycle analysis. Life cycle analysis breaks down the environmental impacts of products and services and puts them in a database and allows you to then strip out the important information like energy and carbon impacts. We're going to take as an example a solar panel. This one actually generates hot water, and we're also going to use a solar electric panel called a photovoltaic panel. Life cycle analysis is a systematic process that looks at the environmental impacts on land, air, water, biology, people, and so on, all the way through from supplier to transport, manufacturing, use and after use and recycling and so on. It integrates the whole thing and ends up with a list of all these different environmental impacts that you get from these. But if you go back to the original question is, how well do renewable energy technologies pay back the carbon and energy invested in them? And I'm going to break that down into 6 chunks. How well? We need numbers for that. Renewable energy technologies, what are they? Well, there are a whole range of things. You could put in nuclear, perhaps, some people do, but it could include things like biomass, burning living, what used to be wood and so on, waste, heat pumps, solar heating, solar electricity, wind turbines, hydropower, even marine current turbines, and so on. So that's renewable energy. How do they pay back? Well, payback is a nice financial accountancy term, and in fact, life cycle analysis is an adaptation of accounting methods into renewable energy and life and environmental studies. So we'll be looking at the years to break even. So, for example, if you chuck a load of energy into making a product, we'll be saying, and it's a renewable energy product, how long before that energy gets paid back? Is it within the life expectancy of the product? Because if it pays back its energy after it's expected to live, it's pretty hopeless. We're going to be looking at 2 parts of currency of environmental impacts. We're going to be looking at carbon and energy. Energy is easy to measure. Carbon is a secondary effect of that, because if you don't, for example, use electricity, imagine you switch a light off, for example, that will reduce very slightly the amount of oil or coal or gas or maybe renewables going into the British generation system. But if you switch that same light off in France, you'd have a different carbon impact because there's more nuclear there, and the carbon intensity, the amount of carbon being used per unit of energy, is actually less in France. So it brings in the idea that life cycle analysis is actually geographically focused, that you get an answer for one country that may work, but not so well in another. So, carbon and energy. Finally, what's initially invested? To get the full details of what actually goes into your product, you have to break it down, quite literally. And when I studied this solar panel, here's a mini version of it, we took it apart in the factory and we took the frame off, we took the glazing off, we took the insulation off the back, we weighed them all, and then we went into databases and we found out what the environmental impacts of each of these were in terms of carbon, energy, killing fish, making people sick, making people wheeze, and so on, and added the whole thing up according to the weight of those products. So, how well do these products in renewable energy products do is quite a big question, because there's a big drive now towards decarbonising our energy supply, and that drive needs to be informed by information. If you were to win the lottery and get 10, 20 grand, what would you do with it? Of course you'd buy a solar panel or something similar, but would you? And if you were So if you want to make an environmentally responsible choice on how to spend your money, and you want to do it on generating renewable electricity or renewable heat or something like that, you actually need to know how much carbon's going to be invested in the kit that you're going to stick on your roof, because it does have a negative environmental impact when you start. And how fast it's going to start paying back. You can just imagine it as any kind of investment. Somebody puts money into a business, they want to break even after a couple of years, and they want then to make a big profit after that. So the same thing goes for carbon and energy. So if somebody asks, how green is my solar panel? It's not some vague, fuzzy question. It's one you can actually give numbers to. And you can compare different solar panels and different forms of green tech with each other. You can answer that question scientifically and accurately, or fairly accurately. And the process that does that is life cycle analysis. And we're just going to briefly look at an example of life cycle analysis using 3 domestic microgenerators. Please excuse the jargon, domestic's not too bad. Microgenerators are small-scale renewable generating technologies. And the ones we're doing at the bottom of this list, they're micro wind, solar photovoltaics, and solar hot water. So photovoltaics make electricity, and hot water is hot water. So the first two generate electricity, and the last one makes heat for washing your hands. Inside life cycle analysis, there's lots of sub-assemblies, and these slides show some of them. Here's a little diagram of the three different types of technologies. There's a horizontal axis wind turbine, that's what HAWT means, but it's not just the pole and the turbine we're going to be looking at. We're going to be looking at the downstream side of it as well, the electronics, the connections and so on. And the same applies for the photovoltaic panel, the solar electric panel. At the solar hot water system, it's not just the solar panel, it's the pump, the plumbing and the hot water cylinder that goes with it as well. So again, we're looking at the big picture. We're not just choosing part of something to reduce the impact and then win an argument by fraud. So, what's the payback in micro wind for photovoltaics and solar hot water? The payback, the break-even time for photovoltaics is about 2 years, solar hot water about 1.5, and micro wind can be as low as half a year, but only if you live in a really windy place where you probably wouldn't want to live anyway. And the study that I did with people at Bath University, which was comparing these three different technologies, listed 8 different impact categories, not just greenhouse gases and energy, but smog and various other things. And we can compare production and operation of these. Production is making them, operation is using them, and as you can see, the production of a photovoltaic system has over 3,000 units of greenhouse gases in it. The operation saves more than 24,000, so it's better. So you can spend a lot of time, just as accountants do, producing ratios of different things. And the carbon payback multiple is 6 times, as is the energy payback multiple, using round figures. And there are also other bits of jargon like carbon intensity that you can look at, which is interesting because we can look at how much carbon is used by different fuels. There's the summary table. Good news. And there are the lifetime multipliers. Micro wind pays back its energy in about 27 years, solar electric about 6, solar hot water about 17. So life cycle analysis looks at the environmental impacts of products, processes or services through the way they're produced, used and disposed, tots the whole thing up, and gives you lots of metrics, lots of things that you can measure. A couple of interesting metrics are embodied energy and embodied carbon. The embodied energy is how much energy is actually needed to make something. So the embodied energy of this solar panel has a figure. I can't remember it, but it's there. And it also has an embodied carbon figure. Here's a little graphic which shows that life cycle analysis doesn't just apply to products like renewable energy products, but also to services like banking. You can actually track in great detail the flows of carbon and energy related to the circulation of $1 through the global financial system. So we need accurate information. Life cycle analysis is about that. It helps us make decisions in our own lives and affecting the lives of others. One of the most important things is the carbon intensity of fuels. You can see on the left side of this graph that coal, diesel, fuel cell and natural gas all have fairly large amounts of carbon dioxide emitted for each unit of energy that they deliver, whereas the renewables, which are on the right hand side, have far, far less. And it raises the question about whether natural gas is a transitional fuel or not. The big discussion going on right now is about fracking. Fracking is about releasing natural gas that's in hard to release parts of the rocks in UK and other parts of the world. And as you can see, natural gas has about half the carbon intensity per unit of energy than coal has. So it's better from that point of view. But if you then look at the carbon intensity over their lives of other forms of renewable energy, they are just so much better. So there is an argument which goes, should we be stopping off at natural gas because we might stay there? Why does no one tell me how green my solar panel is? I think there may be some vested interests here, or people don't really understand how it's important. But it is. In time, I hope that if somebody gives you a quote for a solar system for your house or whatever it is, that they will also talk about the carbon benefits of it as well as the financial benefits, and the carbon break-even time, and the carbon multiple, and the energy break-even time, and the energy multiple, and all that stuff, and you can put that into your decision matrix when you decide things. But at this stage, we're somewhat in the dark. But if we go back to the original question, how well do renewable energy systems pay back the carbon and energy that's initially invested in them? The answer is usually very well, thanks to a process called life cycle analysis. And if you want to know more about life cycle analysis and how it impacts on designing engineering products or any form of design, just contact us at Glyndŵr University.